Morning friends, myself Sachin Jain, Assistant Professor at Ajay Kumar Garg Engineering College in the Department of Computer Science and Engineering. In today's lecture of compiler design, we will discuss 3-address code. So these are the outlines of the lecture. Firstly, we will discuss 3-address code. Second, various forms of 3-address code and data structure of 3-address code that are quadruple, triple and indirect triple. So these all topics we will discuss with the help of some examples. So let's start with 3-address code. Each 3-address code instruction has at most 3 operands and it is a combination of assignment and a binary operator. So when we will write the 3-address code, so we will keep in mind there should be an assignment statement, assignment operator, and there should be binary operator. In a 3-address code, there is at most one operator at the right hand side of an instruction. For example, here in this code, we can see P1 equals to B minus C. You can see that there is a binary operator minus in the right hand side. Similarly, star plus. So, and there are 2 operands, one operator and equal to sign. So, and maximum there are 3 operands, 1, 2 and 3. So maximum there can be 3 operands and 1 assignment operator and 1 binary operator. So there are various forms of 3-address code in compiler design that can be X equals to Y operator Z. Then this operator may be a binary operator. Similarly, X equals to operator Y. There may be possibility that there are no 2 operands, but operator is must. Now X equals to Y, this is also the form of 3-address code. And go to L matlab go to at particular label. So go to particular label can also be 3-address code. If X go to label L and if else X then go to label L. So L here is different, here L is different. So this also may be the form of 3-address code. X remove Y then go to particular label L. So this is also a type of if-else statement with go to label. Procedure calls using parameter X or calling a procedure P or N or Y equals to call procedure P and N. These 3 also the form of calling a procedure of 3-address code. In case of arrays, we can also define array with index value in the form of 3-address code, like X equals to Y index I and X index I equals to Y. So this is also the form of 3-address code. Similarly, pointer and storage location can also be represented in the form of 3-address code, like X equals to and Y equals to pointer Y and pointer X equals to Y. So this is also the form of 3-address code. So these are the various forms of 3-address code that can be used when we are generating the intermediate code in compiler design. So let's take an example. For example, I am having an instruction A equals to minus C star B plus minus C star D. So, and I want to convert this instruction into 3-address code. So what I can write? So what I will keep in mind, firstly, there should be maximum 3 operands. there should be maximum 3 operands. There should be equal to operator. There may be binary operator in the right hand side. There may be single operator operand in the right hand side. So these are the possible value when we are writing 3 address code corresponding to the instruction. So firstly, I assign -c value to the temporary variable t1 like this. Then I take another variable t2 and assign b into this temporary value t1. Then again I take temporary variable t3 equals to -c, and again t4 another temporary variable, and then multiply d into t3. Now another take temporary variable t5 and make a combination of this value and this value. So this is t4 and this one is t5. Sorry, this one is t2 and this one is t4. And then I just combine t5 equals to t2 plus t4 and then assign this t5 value to this a left hand side. So this is the corresponding 3 address code. These are the corresponding 3 address code for the given instruction. We can use different variable name, but we will keep in mind that there should be 3 operands, single assignment operator, and there may be binary operator. And there is a chance of single operand in the right hand side like this, a equals to t5. So these are the corresponding 3 address code for the given instruction. A equals to -c into b plus -c into d. Now next topic is data structure for 3 address code. So there are 3 possible data structure corresponding to 3 address code: quadruple, triple, and indirect triple. So quadruple, as its name says, that there may be 4 fields. One is operator, argument 1, argument 2, and result. So when we are organizing our 3 address code using 4 fields, one is operator, second one is argument 1, third one is argument 2, and fourth one is result. Then this 4 fields data structure is called as a quadruple. If I am writing 3 address code using 3 data structure, then that type of data structure is called as a triple. So triple, there is one thing missing in this triple. There are temporary values are used, and instead of references of the instructions are made, and there is no result field in this triple. So this is the difference between quadruple and triple. And indirect triple is also the enhancement of triple. We will use a list of pointer, separate list of pointer to the triple. So that triple is called as a indirect triple. So we will understand these all 3 with an example. Yes. So if I am having an instruction b into -c plus b into -c. So firstly what I will do, I will write the 3 address code corresponding to this instruction. Then I will try to write quadruple, triple, and then indirect triple. So firstly we will write the 3 address code. t1 equals to -c, temporary variable t2 equals to b into this t1 value, If I am storing this one as T1, then B into T1 will be this T2. So combination of this will be T2. Now similarly, this value is storing in temporary variable T3, and the combination of this and this I am storing into temporary variable T4. And then the combination of this T2 and T4 I am storing in temporary variable T5. And A equals to T5. So there is A equals to this value. So now again A equals to T5. So in this way I just write the 3 address code, and I will try to convert this 3 address code into quadruple. So as I just told you that quadruple is a 4 fields. One is operator, argument 1, argument 2, then result value. So in this case, what is operator? Operator is minus value. And then what is argument? Argument is this C. So I just write minus here, and argument 1 is C. So argument 2 and the argument 2 is missing here, and the result we are storing in the variable T1. So this T1 will be stored here. Now similarly, I just write argument 1 is B, argument 2 is T2, and we are storing result in T2. Similarly, minus argument 1 is C. So here minus is an operator and C is an argument 1. Similarly, in the next instruction, star is an operator. Star is an operator here. Argument 1 is T2. Sorry, this one is a star. Argument 1 is T3. Argument 1 is B. Argument 2 is T3, and the result we are storing in T4. Now next is plus is an operator. Argument 1 is T2, argument 2 is T4, and result we are storing in T5. And then last A equals to T5. Here result we are storing in A, argument 1 is T5, and operator here is equal to. So I've just converted this 3 address code into 4 field record structure that is called as a quadruple. If I want to convert this 3 address code into a record structure of 3 attribute operator, argument 1, argument 2, then this record structure is called as a triple. So what is the difference here in this one and this one? There is no result section, and we are using the reference of all the temporary variables that I take here in the result section. So this result section of quadruple is converted into the reference value of the triple that I will write outside this record structure. So here I am taking T1 as a reference value 0, T2 reference value 1, T3 reference value 2, 3, 4, 5. Now similarly, we will refer these values inside this one 0, 2, 3, 4, 1. So this is called triple. And if I am further accessing this triple value using another reference value, then this record structure is called as a indirect triple. So this thing and this thing both are same, but I'm using a separate reference table to access this reference variable. So for example, I'm saying this temporary location will be accessed through 35 value, 1 will be accessed through 36, 2 will be accessed through 37, 3 accessed to 38, 4 accessed to 39, 5 accessed to 40. So this is the indirectly I'm just referring this this temporary value. So that's why its name is indirect triple. So the difference between quadruple and triple is that there is no result section, and temporary values are accessed to the reference value. And the difference between triple and indirect triple is that the temporary locations are further accessed through the another location values. So I just write 35, 36 here. You can write 100, 101, 102, 103, 104, 105. Whatever values you want to give, you can access these temporary references with another one. That's why its name is indirect triple. So just to convert quadruple, triple or indirect triple from 3 address code, firstly we need to write the 3 address code corresponding to the instruction, and then we will, if I am using 4 record structure, that's called quadruple. If I am using 3 record structure, it's called triple. And further I am accessing the triple reference with another reference that's called indirect triple. So that's all about the 3 address code. Thank you.